models have more in common than you might think initially, and I think we too often stay in our species silos. Sometimes emerging problems have been around and researched for decades in other species. So I think looking cross species is really valuable. And I like to challenge my students to always look at what's being done in other research fields as well, even completely separate from agriculture.
Welcome to the Rumination Podcast presented by Jefo Nutrition. I'm your host, Vicky Brisson. Today's guest is a special one for me. She's the professor who guided me through my master's, helped me expand my vision on complex scientific questions, and I truly wouldn't be here today without all of her help and support. The topics that we'll be discussing today are the ones we've often chatted about, and I hope that by hearing her answers and her explanations, we help you realize the intriguing complexity and importance of mathematical modeling in the world of animal nutrition. With me today to discuss this topic is Dr. Jennifer Ellis, research scientist. Dr. Jennifer Ellis is an assistant professor at the University of Guelph in the Animal Biosciences Department, and she's newly promoted to associate professor as of July 1st of this year. Her research program focus is animal systems modeling, and since joining the university in 2019, her objectives are focused on increasing the digital competency of undergrad and grad students to better support our rapidly advancing sector. Research happening in her lab is cross-species and cross-disciplinary and focuses on building models to increase our understanding of how biological systems work, to identify key patterns and data and extract information, and develop and provide models to the industry for decision support and opportunity analysis. Prior to joining the University of Guelph, she held a research position in the industry, and she brings this real-world knowledge back to her research program now. Welcome to the show, Jen.
Thanks, Vicky. It's a pleasure to be here chatting with you today.
In the last decade, with the rapid advances in technology, modeling is a research method that's growing in popularity. However, mathematical modeling in livestock nutrition has been around for much longer than that. Can you explain models and what limitations they have? As someone with industry experience, how does your real-world perspective influence your research and contribute to academia?
Great. So a model can be described as anything, or it can be anything from a single equation to a set of dozens or even thousands of equations, which represent, in our case, the behavior of a biological system. So scientists will use models to help represent bits of the real world and to either aid our understanding of complex systems or as a tool to help make predictions. So in academia, we often see models used as a teaching tool to try to impart knowledge of system dynamics to students. And we also use them to both generate and test scientific hypotheses. So there's often a really great synergy between experimental research and modeling research, where each kind of feeds valuable information to the other to advance our scientific understanding. In fact, often models evolve in a field because interpreting, the body of knowledge on a topic rapidly becomes more complex than we're able to interpret and integrate without assistance. So these models are often and also widely used in industry, where they act as decision support and opportunity analysis tools for this same reason, right? The complexity. In industry, our models often become the basis for example, feed formulation systems. And in industry, they help us to predict how animals will respond and perform with a given feed management system, for example. Now, because these models are based on either, underlying biological concepts or historical data, they allow us to forecast these outcomes, and when, for example, paired with an optimization routine, find the optimal solution for a desired outcome. Now, you asked about limitations, and of course, all models are a simplified representation of the most essential components of a system. The truth is still the animal sitting in the barn, right? So a model's objective is to represent the most essential components or drivers of that system to aid our understanding and decision making. Now, regarding the time that I spent as a modeling research scientist in industry, to me, that time was invaluable. It gave me a really good grasp on the major concerns and needs of the industry. And I think what I enjoyed the most was developing digital solutions directly in partnership with my end users. And this is something I've tried to carry forward into my academic position with me now. My industry partners are involved in our regular project meetings every step of the way. They bring such excellent real world knowledge to the table as well as ideas. And for me as a scientist, what I really don't want to do is develop an orange when what my partner really needed was an apple. So to me, communication is key in this.
So speaking of actual needs and how we develop models accordingly, new technologies to collect data seem to be released at an overwhelming rate. But having data in and of itself does not mean that we have knowledge. How do models help us turn all of this data into knowledge that actually helps our industry innovate in areas? And, if we think of the current industry needs, we often think of environmental sustainability, animal health, and production efficiency. And while we're on the topic as well, could you also help us define the difference between what a meta-analysis is and what a model is?
So if you ever get the chance, you should really take a look at the ACOF or DIKW pyramid, which essentially describes the steps required to transform data into information and then information into knowledge and then knowledge into wisdom. It's really fascinating when you start looking at that. But essentially, as you point out, data on its own is really just a series of signals. And with just data, we know nothing, right? Data only starts to become useful or it becomes information when we provide context to that data. So we organize it and we structure it. It becomes a little bit useful, and then information becomes knowledge when we introduce meaning into it, right? It becomes contextualized or synthesized, and that's probably the level we get to with experimental research. And then finally, that knowledge becomes wisdom when we can gain insight from it. So we understand it, it becomes integrated and actionable. So essentially, moving us up this pyramid is the task of research, and it's the task of models, right? To translate data into actionable wisdom. So, the topic that we want to gain wisdom on, it can be anything, as you mentioned, it could be animal performance, it could be health, it could be sustainability. There are, of course, many different types of modeling approaches, and it's really just about picking the right tool for the task. But certainly we've seen really significant progress in all of these fields, all of these areas, due to the synthesis of knowledge gained from experimental research or field data into models to integrate our knowledge and aid decision making. So this can be done at various levels, from what's happening at the cell or the organ or the animal or the herd and above. And, for example, increasingly we've been understanding the complexities of sustainability more and more by integrating knowledge from, across all of these levels into things like whole farm models and life cycle assessments. Regarding the difference between a meta-analysis and a model, of course, a meta-analysis is a model. I think the important nuance here is that with the meta-analysis methodology, we integrate information from numerous independent sources, for the most part, scientific publications. And we pool that information, and using statistical methodologies, we expose the common underlying relationships and build models to describe our understanding of that cumulative biological work.
Thank you. So in your introduction, we mentioned that your lab is unique in the sense that you use models to expand nutritional research for many different species, and that includes dairy cattle, veal, turkey, and horses. Can you share with us how that came to be and how your modeling approach is shaped from, I think, what we like to call cross-pollination of many different fields of study?
Yeah, so I started as a ruminant nutrition and metabolism modeler in my master's and PhD. And from there, I think rather organically, I began to get pulled into projects for other species. And in fact, when I went to industry, I was filling the role as a poultry modeler. So I think through my career, modeling has been the skill set, and it's a skill that is repeatedly and, can be applied to a myriad of problems, topics, and species. And I think across species, animals have more in common than you might think initially. And I think we too often stay in our species silos. Sometimes emerging problems have been around and researched for decades in other species. So I think looking cross species is really valuable. And I like to challenge my students to always look at what's being done in other research fields as well, even completely separate from agriculture. So I like to think that although my lab is very eclectic, I think everybody learns from each other by kind of seeing what's happening in other species. So I think that's really valuable.
Thank you. And can you give a few examples of where your students have learned from areas outside of agriculture and have brought that back into their modeling approaches or their research projects?
Sure. There's one subgroup in my lab right now. We're working on some machine learning problems. And, certainly that has been a really interesting exercise to look at. We're looking a little bit at blending modeling approaches. And actually, this has been done quite a bit on the weather side of things. Many weather forecasting models blend, for example, an understanding of biological or weather pattern problems from a real causal pathway with machine learning kind of predictions. So that's a great example of where in weather forecasting and even in water body condition forecasting, that we blended approaches. And these are things that you can take tidbits from to say, okay, that's really cool. How could I use that here to solve this problem?
Fascinating. So, we've talked about what models are and what they are not, and why they're important to research. However, I'm sure many of our listeners are also wondering how this can also apply into an industry setting. And given your background, I'd say you're the right person to answer that question. How can models support on farm decision making? For example, Mafra's Livestock Research and Innovation Corporation, or LYRIC.
So I've touched on it a little bit already, and I hope you've gotten a sense for how models are used as a tool in industry. At the moment, many models are used and applied by what I call expert users within various companies, and those companies will support producers in making on-farm decisions. So you think of your nutritionist, for example. And those models are used, to forecast different scenarios and how suggested changes may impact outcomes such as performance, sustainability, economics. So they can really be used to examine like what if scenarios. What if we did this change? What if we made this adjustment? What kind of outcome are we expecting to see? Now, I think with the emergence of, big data in the animal agriculture sector, the dynamics of model use may change, right? So we have new data streams being collected on farm, and this opens up new opportunities to utilize, different modeling methodologies, including machine learning, which is based on really finding patterns and correlations in large data sets. And this may place models more in the hands or on the computers of producers in the future, right? So to help them interpret everything from changes in animal movement patterns to behavior changes indicating health events, or the ability to track and follow performance of individual animals. So I actually foresee models becoming more and more integrated into, our digitized animal agriculture sector in the coming years.
Speaking of the future of our industry, the future of our livestock industry is new and upcoming graduates. That's where it lies. Based on your experience, why do you believe that modeling is a skill that students should invest time into exploring? And why has that become such a big part of what you do at the University of Guelph?
So I think, as the agriculture sector becomes more and more digitized, with more and more data being collected, it will need more and more graduates entering the workforce with the ability to analyze and interpret and service these digital tools or models. So for me, my biggest piece of advice for students now is to actually learn a coding language, right? Become computationally competent. The challenge the industry has at the moment is that people with that combined skill set, so a knowledge of animal production systems plus digital competency, is low, right? These skills are typically present in separate individuals within a company, right? So we have our nutritionists and we have our data scientists. However, we need people with that combined skill set, right? To bring that biological understanding to interpreting data and building tools that are useful for the industry and solve real world problems. That's a skill set that can really be ported to address a multitude of issues as they emerge. So, to service industry. and as grads move around into various positions through that career. So I think that that's a skill that will become more and more in demand.
When we started off our discussion, we mentioned how modeling has evolved over the years, and certainly these new grads will continue seeing lots uh, of evolving over the future. So as we start wrapping up, how would you define, with your current experiences and your current view on things, the future of modeling? What are the questions that we're still seeking to answer as it pertains to nutritional modeling, in this case, in dairy systems? And what will be the main challenges, but also the biggest opportunities in this area of research and innovation?
So for me, I think the future of modeling is really interesting. And I think what we'll see is the merging of traditional, biological understanding-based modeling, which we commonly refer to as mechanistic modeling, with, blending that with emerging data streams and the accompanying machine learning algorithms that are best suited to analyze them. Each of these approaches has their own relative strengths and weaknesses, and at the moment, they're really running and developing in parallel, but not really interacting. On the one hand, mechanistic models are really great at asking kind of the what if scenario questions. And they're good at that because they're based on a mathematical description of those underlying biological concepts. However, they tend to be developed on like treatment mean data, so from the scientific literature. And while they might predict, the impact of a change on the herd well, the herd average well, they don't necessarily or automatically have the ability to work well at the individual animal level. Machine learning models, on the other hand, they're really based on finding correlations and patterns in data. And as such, if they're developed on an individual animal or a series of animals, they're really well suited to forecast, for example, tomorrow's milk yield or dry matter intake based on historical data from that animal, or maybe other data that's automatically collected on a farm. And where these machine learning models are limited is that they're very database dependent. So we need good quality data to train them to be robust. So for example, if you develop a model to predict dry matter intake for a cow, and that cow gets fed a standard ration all the time, that model will not be able to predict a change if that model has not previously seen or been trained on data that looked that alternate way, right? So I think, to summarize that, I think as we move towards more of that precision nutrition, arena in the field, I think we'll see the merging of these two methodologies. So using mechanistic modeling as that decision-making engine, while using machine learning models to follow and forecast performance for individual animals. So my lab is currently working on or exploring ways to hybridize these approaches to kind of try to capitalize on the benefits of both and augment their relative weaknesses. We've seen some of this development in other species, specifically in the swine sector, some of the work by Dr. Candido Pomar. But I think this will be one of the big upcoming innovations in the dairy sector as well, as we figure out how to take full advantage of the digitization of the sector and essentially the automation of decision making. For all of these new modeling methodologies, I think the biggest challenge will be getting robust and variable enough data to develop them on so that they become good models to make forecasts from.
So, to wrap up today's conversation, can you share 3 take home messages for nutritionists, veterinarians, and producers when they consider applications of nutritional models on farm?
In terms of, I think, 3 take home messages, I think they would have to be number one, get more from your data by leaning into modeling and data analytics. It can really help us reduce the redundant use of animals for experimental research and also get more value from the data that we have and continue to collect. The second one, probably, develop those computational skill sets in yourself and promote it in your employees. If not already, I think it will become in very high demand in the sector as we continue to digitize. And probably the third one is to communicate and get engaged with developers. Real world perspectives are so critical to developing digital tools that can support the sector, they can't be developed in isolation from the end user. So we have to have really good collaborations to make sure that we're building the orange when you need an orange and not an apple. So I think communication is a really key piece there too.
Thank you so much, Jen, for being with us today.
Thank you so much for having me, Vicky. It was a pleasure.
I also want to thank our audience for being with us today. Don't forget to subscribe to Rumination on Spotify, Apple Podcast, YouTube, or other platforms. Feel free to visit jefo.ca for more information. This podcast was brought to you by Jefo Nutrition, precision nutrition for a growing world. Have a great day.